Hello YouTube, welcome to another video. In today's video I'm going to show you how to create a simple neural network with the library which is called Encog. So let's get started. Let's create a new project. I'm going to come here on File, New Project. I'm going to call ML Sample. Okay, ML stands for Machine Learning. Okay, let's click OK. To follow this tutorial, you need to download Encog Framework. Okay, so I strongly recommend that you check out Jeff Hitton's channel. I'm gonna link a link down below. I'm gonna put a link down below so you can check out his channel. Okay, I'm gonna add this library by coming here and add reference. I need to browse until the folder. I think you see libs, Encog core, CL 3.4.0. This is the library. Okay, that's only this. It's just this only file. This file. Let's click OK. And right now we are going to create a simple neural network. Let's talk about what is a neural network briefly. Neural networks are basically a mathematical function that learns something. It's like a way to learn data or to learn a function. Okay. Mathematically speaking, is a function. But actually, we're going to use data to learn that function. So, what do you need to work with neural networks? We need a dataset, which is generally speaking x, y. Okay, x are inputs and y are outputs. Okay, so x can also be known as features, and x can be like represented by labels or confidence and that stuff. Okay, let's create our x. Encog works with double of arrays. Okay, array of doubles. We're going to call this x. Okay, let's create this. If you know C# a little bit, we can also see what I'm doing. We have to create doubles arrays inside this double array. Okay, so let's give this data set some data. I'm gonna basically do a sum data set. Okay, so something like 0.0 comma 0.5. This is if you sum this 0.0 plus 0.5, the result is going to be 0.5. Okay, so very basic, pretty basic and easy to understand. So 0.2, 0.6, you're going to have something like 0.8. Okay, so that is the goal of this program. And 0.5 and 0.5, which is going to be something like 1.0. This is going to be our x or our input data, which is very basic. These are going to be our output data set. Okay, or our output data. So as you see, or as you saw up in the bottom, we are going to just show the values. Okay, so this is our data set. Let's comment this. I like to comment because I think it's more easier to understand. So I'm going to create a region, create data set. Okay, I'm gonna come here and region. Okay, so here I created a data set. That's okay. What we are going to do now is to create the network region. Create network. Okay. To create network, obviously we need to import some namespaces. Unfortunately, we need to import a lot of namespaces when we are working with Encog. So the first one, I think, is the most easier to remember, is their activation, which is under encog.engine.network.activation. We have encog.ml.networks. I'm sorry, encog. Let's see, encog.neuro.networks. Encog.neuro.networks. Okay. Using encog.neuro.networks.layers. Using encog.neuro.networks.training. Using encog.neuro.networks.structure. I think we already can create a network. So the network object is called basic network. Okay, basic network, which is a basic network. I'm gonna call it basic network. This is the network. Sorry. So this network has layers. Layers are the structure of the network. This network has, let's explain the data set. So this data set here is a matrix. Okay, so we have this array, so which has two numbers, and we have this horizontal and vertical. Okay, so these are the inputs. Okay, so this network has two inputs, and we have three samples. Okay, so samples we don't count as and the actuator. We just use them to calculate some training time and something like that. So this network is going to have two inputs and one output. Okay. So, but actually we need to add some something called hidden layer. I'm gonna add a hidden layer with 5 neurons. Okay. So neurons can be also called as connections. Okay. So this network is going to have two, which are connected with 5 hidden layers or hidden layers, which are connected with one output neuron. Okay. So actually, I'm going to draw this because I think it's more easier to understand if I draw something like this. But I'm not going to further in the explanation. So which are we going to do? Let me draw what I'm going to do. Basically, we have their input layer. So this is the input layer, which are 2 neurons, and we have the hidden layer, which are 5 neurons. Okay. Let me see if I can. Let me undo this. 5 neurons. Okay. And one output layer. Okay. So we have this, and we basically have connections between this. So we have a lot of connections, which is going something like this. This is very rushed, but I think you get the idea. This is based on the human brain. So our network is something like this, mathematically or speaking. So we have this matrix, which are a something like let me come here, which is a 5 2 matrix, and this is a 1 5 matrix. So hopefully speaking, we have 2 matrices, and these matrices are called W's. Okay, so we have these W's, which are, let me type here, W's, which are weights. Okay, they are weights. So the whole thing about neural networks is to find the best weights. So let's come back here to the network. Let's add these layers. Let me cut this. Let's add the first 2 layers. Network.add layer, a function. We are going to add a interface to a layer. We are going to type new layer, new basic layer actually. So we have some overloads here. The overload that I usually use is this, which we need to define a activation function. If this layer is gonna to have a bias and the number of neurons. Okay, so the activation function that we are going to use, this is pretty much the most simple one, which is the sigmoid function. This layer is going to have biases, and their nearest count is 2. Okay, so the first this first layer, remember this network has layers. So the first one is called input layer. Okay, the second layer, which can also be the last layer, it's called hidden layer. Okay, let's do pretty much the same thing. Activation function sigmoid true, and 5 neurons. This is the hidden layer, and the last layer, basic layer. I'm kind of lost. That's all these activation functions are going to be the sigmoid function, and this is the output. Okay, so we are not done yet. We need to come here and come to structure to finalize structure. It's kind of a little bit of fuzzy how this network needs so much things to be used, but actually is a good library. It's one of my favorite libraries in C# for machine learning. I think it's the most famous also. You can check Jeff Hitton's channel if you want to learn more about neural networks. Okay, so the network is done. Let's jump to the, let me see. Okay, let's jump to the region training. Okay, training and region training. Let's come to the training. We kind of have how that we need to start the training, but we need to define a algorithm to train this. As you can see, there's a lot of training algorithms. My favorite, or the most famous, is the propagation or back propagation. We have the resilient and back propagation. I'm going to use the back propagation, the most common back propagation. So also we need to create a data set. Unfortunately, we can't pass this to double arrays of arrays directly into the network. We need to convert them to a interface, which is kind of, I don't know. I hope Jeff Hitton changed this to something more simple, because we have to call this two namespacers, encog.ml.data and encog.ml.data.basic. So To create the dataset, we are going to call dataset, or basic ML dataset, dataset is equal new ML dataset. Okay, and we are going. Let me see. I think I'm forgetting something here. Okay. Dataset dot. Oh, I think I'm forgetting something here. Let's try to ML dataset equal your basic ML dataset. Oh, as you can see, we need to create a IML dataset equals a new basic ML dataset, and here we can pass the two arrays as arguments, okay, which are X and Y. So we have the dataset. We need to create an interface for training, which is going to be iTrain. I'm gonna call learner, okay, equal new back propagation, and this back propagation needs the network and the dataset. I'm not going to change the learning rate and the momentum, okay. They are going to be the basic. So let's run this in a loop for int e equal 0 while e is less than 3000 e plus plus. To train, we are going to call learning.train. Oh, sorry, learner.iteration. So this is going to train for 300,000 epochs. Okay. So what do we need now is to verify the network. This is going to train the network. Let's create another region. Testing. I think it's more easier to understand. Test. Okay. Let's run a for loop, or let's just run a for each loop. For each, basically, basic ML pair, basic ML data pair in dataset. Okay, so let's compute ML data. Result is going to be equal network.compute, which is going to run email data. Okay, I think, let's see, pair dot input. Okay, let's run this way. Okay, let's print the result. Let's do something that actually is going to be very easy to understand. Plus this should be equal to this, but the network says that it should be equal to this. Okay, it's going to be fun. So here is the first number, the second number, the result, and here is the network answer to that calculation. So let's come here, pair.input dot I think this is an array, so 0 pair.input 1. Okay, pair.deal 0. Okay, and here we need to pass the result dot. Okay, result 0. Let's see if this is going to work. I don't know if it works, but let's run, because we need to check some errors that may be on the way. Okay, actually works. Let's print the error. Okay, so we can see the error along the way. Error plus learner dot error. I'm gonna press Control F5 or Control Function 5. As you can see the error. Okay, so let's see the results. As you can see, the error is pretty low. It's like very low, 0.00044. Okay, so as you can see here, the network response to 0 plus 0.5 should be 0.5, and the network answer is 0.5, 60.5068. Okay, and as you can see, they are very close, 0.8 and 0.79, 1 and 0.96, very close. So the neural networks aren't perfect, as you can see. They don't return results that are actually exact, but they are very close. So that's the goal with neural networks. So I hope you like this video. I think it's kind of messy, but I hope you learned something from this video. Okay, so any doubt that you have, you can comment down below, and I will answer as much as I can. So that was the video. I hope you like it. See you later.